Algebra lesson 4-1. Alright, we've spent some time working with equations, solving equations, two-step, multi-step equations, and now we're going to kind of shift our gears and start to kind of look into graphing, which we'll be able to then incorporate our equations back into again. So for starters with graphing, we've got to make sure we have some of the terminology down, and one of those is the concept of a coordinate plane. Now, a plane is a flat, we can't actually say it's flat, but let's kind of picture as if it was a flat, two-dimensional, going on forever in this direction and this direction. A flat surface like the smartboard could act kind of like a plane if in reality this could go up forever, down forever, right forever, and left forever. Then it would be like an actual plane. We only have a limited surface here, but we'll pretend as if the flat surface would be the plane. Two real number lines are going to intersect at a right angle, which is a 90-degree angle. So this is what a coordinate plane would look like, which most of you just think of as grid paper or graph paper. So one number line is right here. This is one of the number lines going left and right. And then this is the other number line going up and down. And they cross and connect at a 90-degree angle. Alright? So there's actually four 90-degree angles, but that's what we're talking about here. Two real number lines crossing at a 90-degree angle. Now, if these are number lines, then on this side you've got like 2, 4, 6, 8. So we have positive numbers going to the right like a number line, and we have -2, -4, -6, -8. So numbers to the left are negative and numbers to the right are positive. And on the vertical, when we go up it's positive, 2, 4, 6, 8. And when we go down it's negative, -2, -4, -6, -8. So those are the two number lines. So that means that they cross right here at this location is 0, 0. Alright, it's 0 for that number line, and it's 0 for this number line. We also refer to it as the origin, because that's where it all starts. Everything starts there. It either gets bigger, smaller, according to what we have for our coordinate plane. So that's kind of the gist of the number lines. One number line is vertical, and one number line is horizontal. Now, an ordered pair is going to give us a very specific location on that coordinate plane. If we think about order, that means that it has to be very specific about this, then the next part, and another part. So the order is important. Pair meaning there are two. These are the ordered pair, and it's very specific. X always comes before Y. Just imagine like the alphabet. X always comes before Y in the alphabet. So remember when we write our coordinates, X must come before Y there as well. There are two of them. There's two parts, and they have a specific order. Now, on these ordered pairs on this coordinate plane, as I was mentioning, we have two different lines, all right? And we'll call this the x-axis. So the horizontal number line is always going to be referred to as the x-axis, and the y-axis is the vertical. All right? Now, the ordered pair is important. Say we had an ordered pair of 2, 4. You must pay attention that this is in the location of the x and this is in the location of the y. If you don't pay attention to that and you mix them up, then you'll have issues. So if we were to graph this, we would always start at the origin. That's the beginning. You start at the beginning. Just like where you originate from is where you've started. So origin is the start. And since the first value is the x of 2, we want to go to the right 2. And the second number is a y value of 4, so we go to the right 2 and we go up 4. This would be the coordinate 2, 4. Now here's a common mistake. A very common mistake is somebody puts a dot here and somebody puts a dot there, because they put a 2 on the x and they put a 4 on the y. Each ordered pair represents exactly one dot. That would be 2 dots, so it can't be right. Another mistake, people think it doesn't matter about the order, and maybe they go over 4 and up 2. Well, that's a different location. That's not the same spot. So the order is very important. You always start at 0, 0, which we call the origin, and you'll move to the right or left, depending on the first number. And then you'll move up or down according to the second number. So again, the origin is where we start. And it is always the coordinate 0, 0, because it is 0 for both the x-axis and the y-axis. Take a look at another one now, negative 3, comma 7. Well, negative 3, comma 7 is going to move to the left. We start at 0, 0, and we go left 3 because it's a negative value. So 1, 2, 3, I don't have to put a dot there. I just move 3 and then I go up 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that's negative 3, 7. And if we went negative 6, comma 8, or negative 8, let's make it negative 8. Then we are going to go from 0, 0, we're going to go left 6, then we're going to turn and go down, because that's negative 8. So 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6, 7, 8. Negative 6, negative 8. We always start at the origin, and we move left or right according to the first number. We move up or down according to the second number. This is always x, that's always y. And if we round it out, we could say, let's go 5, comma 0. 5, comma 0, 1, 2, 3, 4, 5. And I don't go up or down because my second number is 0. So that would be 5, 0. So a whole bunch of different places that we could graph. Alright, next we have this idea of graphing. You're going to be asked to graph, and when you're asked to graph, it just means placing a point on the coordinate plane that corresponds. Remember, corresponds is a fancy word for matches. So corresponds means it's going to match the ordered pair. This concept of what I was doing right here was graphing. I graphed each one of these dots and I put them on the coordinate plane. That's what it means to graph. The matching point to the ordered pair. Scatter plot. Now, plotting is the same as graphing. Scattered would mean all over the place. So scatter plots have dots that are all over the place. Analyzing would mean to look at and decide if there's any patterns or data relationships, any data connections, by graphing on a coordinate plane. So I'm going to pull a couple down here to look at. You'll notice that there are 3 different coordinate planes. On this coordinate plane, there's scattered dots, but as you look at them, it seems like they're going up as you look at them from left to right. All right? So if it's going up as you look at it from left to right, you would say that it's positive. Okay, so this scatter plot seems to have a positive connection. All right, the second one, as you look at it, seems like it's going down as you look at it from the left side to the right side. So that looks like it would maybe be a little bit more negative. Now the next one is also negative, but what's the difference between the two negatives? This one's a little more scattered, that one's getting closer to becoming a line. So we might say that this is weak negative because the dots are more spread out. And we might say that this is strong negative because the lines are the dots are closer together. That means that if there's a weak negative and a strong negative, this might also, the positives would have that same concept. We might say this is a weak positive, which means there's probably a strong positive. Strong because it's really getting close. It's not a perfect straight line, but it's awfully closer to a straight line than this is. And then what about this one? It seems to have no connection at all, no correlation. The dots are all over the place. We can't tell if it's positive or negative, going up, going down. We have no idea. It just seems to be all over the place. And the last idea as far as graphing are concerned, when you have a coordinate plane, there seems to be 4 sections that it's broken up into. We call those sections quadrants. 4, just like when you ride your quad at the beach, has 4 wheels. All right, 4 different quadrants. We use Roman numerals. You start in the top right corner and you go in a counterclockwise motion. So this would be the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Now if I draw a big old dot and I move it around, anything that's in this area, if that were the coordinate, it would be in the first quadrant. If that's the coordinate, it's in the first quadrant. Anything over here is the second quadrant. Any dot down here is the third. Any dot over here is the fourth. But what if it's right on the line? Is it in both quadrants? No. You would say it's on the x-axis. You recall, this is the x-axis. And if you found that it was on the other line up here, then you would say that's the y-axis. So it's not in a quadrant if it's on the line, it's on an axis. And if it were right here, then you would say it's at the origin. So it's either completely in a quadrant or it's not. Then it would be on an axis or an origin. All right, so wherever that might be, would be your quadrant. All right, so when you're graphing, really important that you pay attention to the ordered pair, that you understand this is the x-axis moving positive, x-axis moving negative, y-axis moving positive, y-axis moving negative. And the order is always start at origin and move right or left according to the first number, up or down according to the second number, and each ordered pair means one dot.